So this is actually a 3-credit course and also compulsory course for all of you, which is offered in the first semester of your degree program. And there will be 6 compulsory online classes for you, and we will be providing the lecture materials as well as the recording in the LMS. And so this year, as a new, we have also included 2 online guest lectures for you from different experts in the globe. And so talking about the course, so there will be one assignment for you. This is basically a case study where we will be grouping you into 4 to 5 students, or maybe this time we have a high number of students, or there will be more number of students per group. And there will be one continuous assessment test that we called as the CAT test. So this is again one online test, and there will be a final online examination. So this is a 3 hours online examination. So this is the overview of the schedule. So the coordinator, the academic coordinator is Engineer Ruchirabe Veera. So if you have any questions related to this course, in overall, so you can contact him, either him or maybe as a part of the academic committee. I will also be there available for you to answer any question related to the course. And so this is activity schedule. So there will be 6 online classes, as I have mentioned. So today is the first online class, and the second online class will be on 20th of the May. So I will be conducting the first 2 online classes, and there will be some other teachers, panel of the teachers who will be appearing for the other online classes. And so the final examination falls on 6th of September, and you can have an overview of the entire schedule. And the eligibility criteria is this case study. CS means the case study. So we are taking 40% of the case study, and we are taking 60% from the continuous assessment test, and then calculate to see the whether you are eligible to sit for the final examination. So all the course materials and the assignment submission links and the continuous assessment test, everything will be managed through the learning management system. And I think you have already received the information. If not, you will be receiving them soon. And once you logged into this LMS, so you will be getting all the courses overview and all the information, detailed information about each and every course that you have registered for this semester. So if I talk a bit about the teachers of the course, so there will be several teachers coming from different parts of the world. You can see from France, Sri Lanka. So they are all contributing to the development of the course as well as to the delivery of the course. So before we move to the course, so I thought as one of the panel members of the teachers, so I thought to give an introduction to myself. So I'm an BSc in agricultural engineering graduate from University of Peradeniya, and then I did my first master's in agricultural and biosystems engineering again from the Peradeniya. And then I migrated to Germany to do my second master's in hydroscience and engineering, and then I continued to complete my PhD in hydrology at the same university. And a little bit about my work experience. So I have worked as a research assistant at the Solid Waste Management Research Unit of the University of Peradeniya soon after my graduation. And also I contributed to work in an NGO, local NGO, in collaboration with the International Water Management Institute and the World Vision Canada on wastewater related research projects. And while I was in Germany, so I contributed to the university as a scientific researcher while doing my PhD. And after completing my PhD, I joined the Open University of Sri Lanka as a senior lecturer attached to the Environmental Studies and Sustainable Development Center. And currently I serve as the director for the career guidance unit as well. So professional experience and so I serve as the DAD research ambassador for Germany, representing Sri Lanka, and also an accredited green professional for the Green Building Council of Sri Lanka. And I've served the Green Building Council as the National Cleaner Production Center as an auditor for eco-labeling and also an NVQ assessor. So moving to the course content, so this is basically divided into two sections. So the part one is introduction to circular economy for energy. There you will be having four lessons. So today will be the first lesson, overview of the circular economy, and the next lesson is on the key features of the circular economy. And you will be exploring more about the circularity of the materials, life cycle assessment, and so on into the in the part two of the lectures. And so what are the intended learning outcomes of this course? So at the end of learning this course, you should be able to describe or the differentiate between the circular economy and the linear economy, what is currently what we have, and then should be able to describe the benefits and the limitations of the circular economy and explain how circular economy principles can be integrated with the sustainability principles, and to describe the basic definitions for circular economy indicators. So this is basically targeting on this lecture today. So to begin with, if we talk about our economies, or if in our current economic model, so the manufactured capital, the human capital, and the natural capital all contribute to human welfare by supporting the production of goods and services in economic process. So where the natural capital, that is the world's stock of natural resources provided by the nature before the extraction or processing by humans, that is typically used for the materials and energy inputs into the production, and that actually act as a sink for the waste from the economic process. So this economic model can be described as a linear, which typically involves economic actors who are people or else the organizations engaged in any of the four economic activities, that is the production, distribution, consumption, and the resource maintenance. So in the end, harvesting and extracting the natural resources, using them to manufacture a product, and then what we do is selling a product to other economic actors who then discard it when when no longer it serves its purpose. So therefore, the natural resources in a linear economic model or in the current economic model can become inputs, and they can become outputs, or else they can accumulate in the man-made stocks where they are stored in the forms of buildings, or maybe in the transport infrastructure, or durable or semi-durable goods, such as if I give you an example, like cars or whatever the machinery that we produce. So this linear economy, following the take, make, use, discard model, is based on a false premise that the resources are infinitely available. So we assume that the resources are infinitely available and accessible at an affordable cost. So we don't think that the resources are finite, and we cannot access them all the time. So in terms of money and also in terms of their environmental impacts. However, in reality, such a pattern cannot sustain by the earth system because of two reasons. Because we know that the sources of the material are infinite, they are finite, and also there are limits to the availability of the earth's ecosystem to recover them from the natural habitat, uh, and also recover from the degradation and pollution by various hazardous and other chemicals. So the disadvantages of the linear economy is, that is the most significant disadvantage is that we are having a linear approach, that we are extracting the natural resources, what we produce whatever we can, and then we just generate waste as much as possible. So this concept take materials, and not only the materials, but we use energy as well as the water to make something useful for them, and then you just throw them. So and ultimately it will end up in a landfill or maybe in an open area. So main disadvantages, as I mentioned, so they are the extraction of the natural resources that we refer to as the take. So the collection of the raw materials from the earth's surface takes a lot of energy as well as a lot of water. So these extraction processes, they lead to destruction of the natural areas through the removal of the forest and disruption to the river systems, or the removal of the large amounts of soil and rock, changing the entire landscape. So it can also create a great deal of pollution, such as the carbon dioxide emissions, or maybe it can release other toxic substances. So the other disadvantage is a wasted effort. So the process of designing a product is involved. So it starts with the generating a concept, so design, and then we screen the idea and making a prototype. Then we do the testing on the prototype, and then do the product development for the developments, and then manufacture it, and then sell it to market using different marketing approaches. And then we transport the products, do the sales, and finally it reach the retail and then the consumer. So all this, and then after a short time we can so easily discard the items. So this is what we currently do. And again, through this circular economic model or the concept, so we do have a throwaway mentality. That means it appears to us as consumers that there is a never-ending supply of goods, unfortunately, the majority of which end up as waste. So we are grappling with the throwaway mindset created by the linear model. So it is deeply ingrained into our societies and the culture. So this current linear economy has contributed to a throwaway society where the objects have a low value and throwing them away comes naturally. So there's a great deal of work to be done to switch the entire world from the Western economies through to growing economics out of this way of thinking. And finally, the pollution. So this throwaway mentality is what leads to the pollution. So the low value placed on the natural resources in many of the objectives, particularly if you take the single-use plastics, that can lead to them being disposed of in the environment. And a great example of this is the pollution we see in the ocean today. So it occurs through every phase of the linear economy model, starting from the natural resource extraction. So from the extraction and use of resources through the manufacturing phase, and then the pollution that results from the waste generation. So when products reach the end of their useful life, then they are discarded, they fill up the landfills, and also not only that, they are releasing the toxic chemicals, they pollute the natural environment and can stay around for centuries, or you name it. I don't have to explain it further. We evidence these consequences of this linear economic model that we have. So, so what is circular economy? So the circular economy is a model of production and consumption which involves sharing, leasing, sometimes we are reusing and repairing, maybe refurbishing or recycling the existing materials as well as the product as long as possible. So in this way, what we can do is we can ensure that the life cycle of the products is extended. So in practice, it implies reducing the waste to a minimum. So when the product reaches the end of its life, so its materials are kept within the economy, whatever possible, so they can be productively used again and again, and thereby creating a further value to the product, further value to the raw materials, and maybe we can add further value to parts of the entire product. So we are trying to reuse, uh, re, uh, reuse the whole product as it is, or else if it is not possible, then we try to disassemble part of the entire product and then see whether we can cycle them in the circular economy. So this is what we are basically talking about, the circular economy, so which can be applied into many different sectors in the industry. So this is actually, we can say, as a departure from this traditional linear economic model, which is based on this take, make, consume, throw away pattern that I explained above. So this model relies on large quantities of cheap and the easily accessible materials and the energy. So it can be explained easily or simply by using this figure that you can see here. And so again, this is another diagram showing how the circular economy model works. So starting from the raw materials, then we are thinking of a sustainable design, and then this sustainable design leads to production of whatever the products and the services, and then it is distributed to the end user or the consumer or the customer, depending on the situation. And then the consumption takes place, and whenever possible, as much as you can reuse, repair, refurbish. And then finally, when it is to be discarded, then we have to do the proper collection, the segregation. And through this proper collection and the segregation, you can lead that to the recycling of different components of the product, and whatever not possible, then ultimately it goes as the residual waste. So this residual waste can be ended up depending on the nature of these residuals, it can either end up in a, a landfill or many other destination. And so this is about the principles of the circular economy. That is, whatever we talk about the circular economy, so all these are based on these three principles. So the first principle is about the eliminate the waste and the pollution. And the second principle is about the circulate products and the materials at their highest value. And the last one is about the regenerate nature. So we will be looking into these, each of them in the coming slides. And about the first principle, that is on the eliminate waste and the pollution. So we know that currently our economy works in the take, make, waste system. So as I mentioned earlier, we take the raw materials from the earth, we make products from them, and eventually we throw them away as waste. So much of this waste ends up in landfill, or sometimes we subject them to the incineration, and then it is lost to the environment. So this system cannot work in the long term because the resources on our planet are finite. So therefore, the problem as well as the solution starts with the design. So for many products on the market, there is no onward path after their use. So for instance, if we take a multi material flexible packaging, plastic packaging, that cannot be reused, it cannot be recycled, or it cannot be composted. So what happens is that it ends up as the waste. So for products like these, so the waste is, we call this as the waste is built in that product. So they are designed to be disposed. They are not to be reused. They are not to be recycled. They are not to be composted. So although it sometimes seems like waste is inevitable, so we say that we cannot get rid of the waste. So it is in certain situations it is true, but because the waste is actually as a result of the design choices. So we can say that it's a design flow. So there is, but on the other hand, if you look into the nature, so there is no waste in the nature. So it's a concept that we as the human beings have introduced. So from tiny short-lived products like, as I mentioned, so maybe a packaging of cookie pack, or all the way up to seemingly permanent structures like we are talking about the buildings like massive structures, the roads, and so the entire economy is filled with the things that have been designed without asking the question, what happens to this at the end of its life? So that's the main problem in the current linear economy. So by shifting our mindset, what we can do is we can treat waste as a design flow. So in a circular economy, there is a specification for any design is that the materials re-enter the economy at the end of their use. And by doing this, we take this current linear economy and try to make it to circular. So many products could be circulated by being maintained, by being shared, reused, repaired, refurbished, or manufactured whenever it's possible, and then finally recycled. So if you take the food and other biological materials that are safe to return to the nature, of course, you can do it so that it will regenerate the land and fueling the production of new food and the materials. So as circular economy has become more widely accepted as an attractive way forward. So what the companies around the world do is they rethink the design, they make it, and then remake the product. So if I give you some simple examples for circular economy for you to understand where you have no idea at all. Uh, so this if you look into the packaging industry, this is a massive industry. So they have designed the reusable packaging, and sometimes you can see some examples for on the edible packaging, or sometimes no packaging. So we call them as the nude packaging, as a way to eliminate the waste. So if you look into some other sectors like textile industry, they are not using the water so that it can reduce or eliminate the toxic wastewater generation, and then they're looking into different other approaches how they can do it. So this is another example where we can reduce the waste and pollution. So either you used the edible packaging, or maybe you can go for the zero waste packaging whenever possible. So here in this slide, what you can see is some avocados with an edible wrapping. So you can see the edible wrapping here. So this is applied and it comes to the market as a powdered format. So this is a very good innovation by a company called Appeal. So that has come up with an edible peeling or edible wrapping. So this is an innovative way to eliminate the single-use shrink wrap plastics that you see every day in the supermarkets on uh, fresh fruits and the vegetables. So while at the same time that is tackling the food waste. And so this is, as I mentioned, it is edible and also a plant-based coating, which is applied to the fresh products. That is like mimicking and enhancing the natural defenses on the fruits and vegetables. So this, what happens is once you apply this edible sealing or the packet, the wrapping. So this slows down the two main things, and that can cause the spoilage and the water loss as well as the oxidation. So thereby you can keep it, or you can increase the shelf life of the product. So this is distributed to the partners as the powder format, and then once you receive it, so you can mix it with the water at the packaging centers and can apply it as a spray, or maybe you can dip it into these solutions, or maybe you can apply or brush it on the different methods, so that according to the research that they have found that they can keep the fruits fresh 2 to 3 times longer without the need for plastic packaging. So this is about the zero waste packaging made from the seaweed. So you might have heard that Indonesia is the world's second largest contributor to the plastic waste in the ocean. So 70% of the plastic waste comes from single-use food and beverage plastic containers. So the company called the EvoWare, so it's a company that offers environmental friendly, biodegradable, edible, and nutritious products used for packaging and replacing the conventional plastic packaging with the seaweed as raw material. So the people can eat this food packaging, and then they can take advantage of its nutritious seaweed, which contains, that it has high fiber, vitamins, as well as the minerals. So this helps the environment by reducing the plastic contamination in the ocean. And then on the other hand, if you look into the livelihood of these poor seaweed farmers, so that it also improves. So you can see some of these edible bioplastic sheets or sachets that they have produced onto your right hand side of the slide. So that is the seasoning sachets. You can store the sugar, coffee, toothpicks, to the sanitary napkins and other customary packaging with different colors. And this is about the zero waste packaging, as I mentioned. So this is called a very good example that I took from the internet. That is, you might have heard about the Lush company. They are producing all the cosmetic and personal care products. So they have thought of eliminating or getting rid of these plastic bottles coming as a packaging of their personal care products. So they have redesigned some of their liquid personal care products to solid formulation so that they can reduce the plastic packaging. And this is about the eliminating waste and pollution that I have mentioned. So this is not limited to the packaging industry, but also into some other industries like textile industry. This is again a very huge polluter. And if you have heard about this textile company called Daiku, so they have developed a technology for dyeing textiles without using the waste and thereby eliminating the toxic wastewater generation. So instead of water, they are using carbon dioxide as a solvent in a closed loop system. So while the capital investment in the equipment, in this kind of equipment is much higher than that of the conventional dyeing, by the company reports, it can reduce the operating costs due to the short batch cycles and also the efficient dyeing process and the avoidance of the wastewater treatment. So that this technology can also reduce the health and safety risks by minimizing the workers' exposure to these kind of toxic chemicals. So according to this company and the literature available, so one of these kind of Daiku's machines can process up to about 800 tons of polyesters per annum annually, and thereby they can save 32 million liters of water. Imagine the amount of water that they can save. And at the same time, they can avoid the use of 160 tons of chemicals and completely eliminate the release of wastewater into the natural environment, where it can reduce other negative consequences that it can impact on the environment. So I think that's all about the examples, and I'll be giving some more examples in the coming slides. And we'll come back to talking about the principles of the circular economy. So, as you can remember, there are three principles of circular economy. So, the second principle is about the circulate products and the materials at their highest value. So this means keeping the materials in use either as a whole product, as I mentioned earlier, or else when that can no longer be possible or to be used as a whole product, then we can think of the components or the raw materials and then try to keep them in the circle. So this way nothing becomes waste. And the intrinsic value of the products and the materials can be retained in this way. So before discussing further into the second principle, so I would like to introduce two terms with regard to the circular economy. So in circular economy, we distinguish two types of materials. So they are the biological materials and the technical materials. So biological materials are used to make the consumption products that we say, which get consumed during the use, like if I give you examples like soap or maybe the shampoos or maybe some materials or the products that wear off during the use like clothes or the shoes. So these are designed to be safe for human health and the environment, so they can safely return to the natural biological cycle. So talking about the other material, that is the technical material. So the technical materials are the materials that they are used to make the service products, such as if you take a very simple, easy example, you can take the mobile phone, your mobile phone, or maybe the computers, laptops, and the telephones, maybe the washing machine that you use, and also the vehicle. So they are coming under the technical material. So as they are non-renewable and they are often hazardous to human health and the environment, so they are kept within the industrial technical cycle where they will be used to make new products. So I'll be showing these two materials, how they are circulating in the circular economy. So, therefore, for the materials to be recovered and returned to the next cycle of the production, so they need to be clearly defined in the circular economy. whether they are coming as a biological material or whether they are coming as technical or technical material. So there are a number of ways the products as well as the materials can be kept in circulation. And if I say that it is helpful to think about the two fundamental cycles, these two fundamental cycles, as you can see in this picture, so I have included as two separate figures, the biological cycle of the consumption and the production, and the technical cycle of service products. So if you take the technical cycle itself, then the products can be reused, repaired, or remanufactured, and whenever possible can also be recycled. But in this biological cycle, where we are talking, or where we are more focusing on the biological materials, they can be returned to the earth through different processes like composting, and also they can be subjected to the anaerobic digestion, where in simple terms subjected to the biogas production. So the biological materials, further, they can sometimes be considered as the cascading material. You might have heard about this term. So because some materials allow them perfectly to be cascading use. So as you can see in this picture, after the production of the garments, onto your right hand side, if you look into the diagrams, or you can see the term garment, and these garments can be used as a rug after using it for a long time. And after some time, this rug can be used to stuff furniture. And then maybe finally you can use it as an insulation material, where you can break it into smaller particles. And as such, we can use it in defined cascades, where the quality deteriorates from one cycle or one application to the next, but both along the way and in the end, the material can be fully returned to the biological cycle. You can regenerate, reintegrate it to the nature. So in the end, they can be processed under aerobic composting or anaerobic digestion to recover resources such as the organic matter, maybe the nutrients, maybe the energy. So if we talk a bit about further to the technical cycle, so this is the most effective way of retaining the value of the products, is to maintain and reuse them. So if I give the very simplest example, that is your mobile phone as an example. So if it is far more valuable as a phone than as a pile of components and the materials. So the first step in the technical cycle are focused on keeping the products uh, whole to retain the maximum possible value. So this could include the business models based on sharing, so the users get access to a product rather than owning it, and more people get to use it over time. So sometimes maybe you want to go for the different models, maybe the high-tech models. So what you can do is you can either sell this product, or maybe you can share it with some other person so that it can be reused as a product as a whole. So and eventually, so when this product can no longer be used as it is, then the components can be remanufactured. Maybe the parts that cannot be remanufactured can be broken down into their constituent materials, and then they can be subjected to the recycling. So while the recycling is the option of the last resort, but because it means the embedded value in the products and the components are lost, so it's very much important as the final step, which allows the materials to stay in the economy and that it does not end up as a waste. So compared to the technical cycle, the biological cycle, that cannot be reused sometimes, if you take the food products, so that cannot be they can be circulated back into the economy through the biological cycle. And as I mentioned, so maybe the composting and anaerobically digesting into organic material, and you can apply them in the agriculture or whatever other applications. So uh, however, if you take some products like maybe if you take cotton clothing, or maybe the wooden furniture, so that can be circulated through both the technical and the biological cycle. So they can be maintained, reused, repaired, and sometimes be even recycled, but eventually they can be returned to the biological cycle from which they came. So either the composting or maybe the anaerobically digestion, so that they can be returned to the nature. And this is, if I don't explain or if I don't show this very famous diagram that we call as the butterfly diagram of the circular economy. So this has been introduced by the Ellen MacArthur Foundation. So you can find a lot of information from their website. So I have taken this figure also from this website. So this is very famous, and where they are talking about these two main cycle, the biological and the technical cycle that I have been explaining. So this is so for all what I've been explaining. So design is the key to success in the circular economy. So in order for the products to successfully be circulated in either the biological or the technical cycle, so it is essential that they have been designed with their eventual circulation in mind. So at the design stage itself, you have to think what will happen to this product at the end of their life. So also there are products that sometimes that fuse the technical and the biological materials in such a way that we can't separate them and circulate them. For example, if you take the textiles, so the textiles, there are sometimes the textile that come up or that blends the natural and the plastic or the synthetic fiber. So in that case, it's very hard to separate them and think of the circular economy approaches at the end of their use. So if the designers thought about how their product could fit into the technical or the biological cycles that I've been explaining after their use, so that the product could be made with that onward path in mind. So for instance, the products destined for this technical cycles, they would benefit from being easy to repair and maintain, easy to take apart of different components, and made of modular components that can be replaced. So they could be durable enough to withstand and wear and tear of the many users. So if the products like wooden furnitures, as I mentioned, so they can be easily maintained and repaired with the biological cycle in mind, so that they are biodegradable materials like the wood, so that would be easily separated from their technical materials. Like you need the screws and all to fix these wooden parts. And if you take the glues and the paint, so that they cannot be actually biodegraded. But if you have a good design so that these screws can be separated and the wooden parts can be reused, or ultimately you can blend it back to the nature. So when you talk about the design for circulation, and in the world of the circular economy, so product circularity aims to maximize the value of the components and the materials of the products during the longest duration. So the product life extension can be attained, as I mentioned repeatedly, the repair, remanufacturing, and refurbishment. It is the central economic and the social model. So under the circular economic design, so we are defining five main characteristics, that is of the circular products from the inner loop, as I have included in this figure. So from the inner loop to the outer loop, as the future proof, the product should be future proof, and it should be able to disassemble or design for disassembly and maintenance, remake, and the recycling. And so this is further to this design for circulation. So future proof means last for long use, and so it lasts for long and you can use it for long. So that means the performance, reliability, and the durability, everything is included. And the use long means the adaptability of the product and the upgradability, timeless design, etc. And the second one is about the disassembly, love to service, remake and recycle. That means you can think of the product architecture, and you can go for the simplified product architecture, which allows the ease of access to components and clarity of the disassembly sequences, etc. And then the maintenance, that is the reuse of the products. So ease of cleaning, ease of repair, and ease of upgrade, so that it allows on-site repair or on-site upgrade. And lifetime prognostics, that is the online monitoring for quality, testing, maintenance, and milling, etc. And the remake, that is reuse of the parts. So modularity can be think at the design stage, and you can use modular components to come up with the product, and then you can standardize the interfaces, and back and forward compatibility can be thought at the design stage. And then the recycle, that is reuse of the materials. So the materials avoid the use of non-compliant coatings, where at the end you cannot separate them. So only use the materials that can be recycled, and use preferred or pure materials whenever possible. And if you look into the electronics, sorry, then the ease or the fast detection of the materials is very good at the design stage, if you can think of. And then the connections, like avoid the fixed connections, and you can think of the breakdown by shredding or disassembly, so that into pieces of uniform composition and pieces of relatively large size, etc. So this can be applied into different products and in different fields. And this is an example again for an innovative packaging that can be returned to the earth after use as a part of the biological cycle that I explained, which is made using the agricultural waste and using the fungi mycelium. So the founders of this innovative design were inspired by the way the mushrooms growing on the wood chips bonded them together with their roots, the mycelium that we call. So if you don't know, the mycelium is a fungal network of thread-like cells that acts like a natural self-assembling glue. So it grows in 5 to 7 days without needing any light or water, so that digesting the agricultural byproducts and then binding them into any shape that is needed. So this is an application of such a thing, and this can enable this innovative team to create a new method of producing materials that can replace the various products like packaging. So including the petroleum based expanded plastics and the particle boards, which are made using carcinogenic formaldehyde. And when we consider the textile industry, I gave just one example where you can reduce the wastewater generation. So there is a challenge in the textile industry that is related to the stitches or the stitched clothes, such as jeans or the jackets, that need to be taken apart before their constituent materials can be recycled. When you think of the circular economy approaches that can be applied, so the existing disassembly process is in these textiles is a time consuming, as well as it is expensive, because as the garment and its components, they are held together by a synthetic high strength thread. And this is which is most cases is the this is a polyester. So before recycling the garment, that has to be separated, and this polyester thread is to be removed, otherwise the quality of the recycled product will be compromised. So the Resartec, or this called this recycling, sorting and technologies company, so they have designed a new type of thread that can, or that makes the disassembly process faster and easier. So their threads are available for different melting points, such as at different degrees of Celsius, like maybe from 150 degrees Celsius, 170 or 190 or 200, and they are dissolving using a commercial oven. So you put it into the oven and then set a particular temperature, and these threads, the polyester threads, are melted. So the choice of thread depends on the type of the garment that is being taken apart, and then you can easily recycle or apply whatever the techniques that you want to apply in recycling these the textile garments. And that's all about the second principle of circular economy and examples related to it. And here, what I wanted to talk about is the third principle, that is the to regenerate the nature. So uh, by shifting our economy from linear to circular, so what we do is we shift the focus from the extraction to regeneration. So we are not really focusing on natural resource extraction, but we are thinking of the regeneration. So instead of continuously degrading the nature, we build the natural capital. So we employ the farming practices. If I take an example that allows the nature to rebuild the soils and increase the biodiversity and return the biological materials to the earth. So currently, the most of these materials are lost after use, and the land used to grow them is actually depleted of the nutrients. So if we move to a regenerative model, we can begin to emulate the natural systems because, as I mentioned at the beginning, there is no waste in the nature. So when a leaf falls, if you look into the nature carefully, when a leaf falls from a tree, it feeds the forest. So for billions of years, the natural system have been regenerated themselves, and waste is actually a human invention. So the obvious place to start when shifting to an economy that regenerates the nature is the food industry. So the way we produce food today is a significant driver for both climate change and the biodiversity loss. So it relies upon ever increasing quantities of the synthetic fertilizers that we apply, the pesticides, the fuel, the fossil fuels, and also the freshwater resources and many other finite resources. So these are a source of pollution and damage to the ecosystem and the human health. So if we produce our food regeneratively, the focus is on improving the soil health. So the regenerative farming practices, they can significantly reduce the greenhouse gas emissions from the food production, and by reducing the reliance on the synthetic inputs and by building the healthy soils that can absorb rather than release carbon. So, and on the other hand, as well, like helping restore the natural carbon cycles, or healthy soils are better able to hold water, and its water holding capacity increases, and also it reduces the impact of droughts, and they are better able to absorb water and reduce the risk of flooding or the extreme climatic events that we face today. So these kind of regenerative food production practices can include like agroecology, we call as the agroforestry, where you are growing trees around or among the crops or the pastures, so that it could in results in agricultural land that more closely resembles the natural ecosystems like forest. But on the other hand, you can produce whatever the food requirement, and so it provides a good habitat for a wide range of organisms, not only the human beings but also other uh, animals, and also it can increase the biodiversity, it can maintain the biodiversity, this using these kind of approaches, and it reduces the need for the synthetic fertilizers that we apply into the agriculture, and also it can increase the pollinators like the bees, and also increase the population of the microorganisms in the soils, or which are essential for the maintenance of a healthy ecosystem, and where we can thrive or live. So there will be more space for nature. So in addition to the food system, there are the benefits for the natural ecosystem by adopting a circular economy, because by keeping the products and the materials in use, then there will be less land requirement for sourcing the virgin raw materials where we are extracting from the mines. So if we gradually decouple the economic activities from the material extraction by keeping the materials in circulation after use more and more, and then the land can be returned to the nature, and maybe the rewilding can happen eventually. So in a circular economy, land dedicated to material sourcing will increasingly be focused on the renewable resources, and also we are growing them in a regenerative way rather than the extraction of these finite materials which will increasingly remain in the circulation. So all this will be underpinned by a transition to 100% renewable energy produced using the infrastructure designed for reuse, repair, remanufacture, and recycling, etc. And on the other hand, we can tackle the climate change. So by transitioning to renewable energy alone, we'll only tackle like maybe 50 to 55% of the global greenhouse gas emissions. And the rest comes from the way we make and use products in and the food and the way we manage the land. So this is where the circular economy comes in. So it is estimated that the economic and health and the environmental benefits of a circular economy for food alone would be somewhere around like 2.5 to 2.7 trillion US dollars worth in 2050. So if you adapt the circular economy principle, the food industry could actually halve its projected greenhouse gas emissions by 2050. So I can give you a very good example for a company that regenerate the nature. So if you have it about it, it's called the Natura. That is South America's largest cosmetic company, and it is the fifth largest beauty company in the world. So what they do is they produce a huge range of products, including like soaps or maybe the creams and the shampoos, all of which rely on the rich biodiversity of the where the Amazon for the ingredients as well as for the materials. And they are not only extracting or getting the materials from the Amazon, but they are also using the biointelligence, that is the knowledge of the indigenous communities to come up with these kind of products. So according to the company supply chain that includes almost like 40 types of plant derived ingredients, and there is an involvement of about 7,000 families who are dwelling in this Amazon region. So the key element of this Natura's business model is the concept of the standing forest economy. So in simple terms, if I explain, that is the meaning is that if you take a tree as a tree, it has much more economic value than standing than it is felt. So this is the philosophy that they are using in the Natura company, so that they can, or they have preserved over 2 million hectares of the Amazon's rainforest, with the goal of increasing this area to like to 3 million hectares by 2030. So that's all about, I can talk on the regeneration. And in this slide, what you can see is I just want to discuss a bit about the applications of the circular economy principles in different sectors, rather than talking all the way about the energy, but you will be getting more exposure about the energy sector and the circular economy application in the coming lectures. So just today, I just want to give an introduction to the entire course. And so this is the first application, that is the plastics and the circular economy. So we know that plastics are very versatile materials, but the way we use them is incredibly wasteful. So we take the oil and the gas from the earth to make the plastic products, and that are often designed to be used only once, and then we throw them away. So we know that this is a plastic is a byproduct from the crude oil extraction. So this is what we call a linear take make waste model, that or the linear plastic system here in this scenario. So is it possible to rethink the way we design, use, and reuse plastics to create a circular economy for plastic, is my question. So if you look into the statistics, then annually millions of tons of plastics worth billions of dollars, they ends up in the landfill, and it is either burned or maybe leaked into the environment. The toxic components that is remain in the plastic can be released to the environment, and it can create massive pollution. So according to the statistics, 8 million tons of plastics are leaking into the ocean every year. So that's a very big number. And this number is not stagnating, but this number is increasing, the rising value. So according to the reports, if we don't think, if you don't rethink its use, then there will be more plastics in the ocean than that of the number of fish by weight by 2050. So is it possible to rethink the way we design, the way we use and use? That is a question. So how can we design a circular economy for plastic in which it never becomes a waste or pollution? So we my question is, can we do more beach cleanups and then end up this pollution? So beach cleanups we do many times, and we are doing it in different places, but they are needed to clean up the waste already in our environment, but they are like far from enough, if I would say. So even if we manage to clean up the current plastic in the environment, so more and more plastic could leak into the environment every day. So in every minute, one garbage truck of plastic waste enters into the world's ocean. So therefore, we need to stop plastic leaking into the environment. So the beach cleanup would not uh, be a sufficient solution to get rid of the plastic. So the second question is, can we burn or can we ban, sorry, can we ban all the plastics and replace them in another material like when in the waste management we call it like you can include them into the glasses, or maybe you can blend it with the paper or sometimes with the aluminum. So the answer is like yes, in some cases, of course, you can do the banning and it can be a solution, but substitution of the plastic with other materials that can lead to significant negative, like unintended consequences, like increased carbon emissions, water use, and the food waste. So, therefore, if you take every case every case, we must take a holistic approach, looking as the whole system in which a material is used, from sourcing and production to use and after use. So the best solution I would say is to redesign the entire plastic system. So we need a systematic approach to create a system that works in practice without loss of economic value and no plastic waste or pollution. So we have to or we need to rethink the way we make, where we use and reuse plastics, essentially redesigning the system in which the material is used. So in before I move to this one, I think some other questions that came into my mind is like, can we eliminate the plastics we don't need? So is it a good solution? Because we know that the plastics bring many benefits, and at the same time it brings a lot of problematic items to the market that needs to be eliminated in order to achieve a circular economy, the so-called circular economy that we talk about. And sometimes we can avoid the plastic packaging together while maintaining its utility, and also while improving the recycling, that is which is very crucial, and we cannot recycle our way out of the plastic issues we currently face because of the complexity of the materials of the plastic that we are using. So therefore, wherever relevant, reuse business models, I mean, they should be explored as a preferred solution, like maybe in the inner loop of the circular economy terms. And you can reduce the need for single-use plastic packaging, and you can think of the reuse models which provide an economically attractive opportunity for at least like 20% of plastic packaging need to be implemented in practice, and also at a scale. So what we should do is we should innovate to ensure that the plastics we do need are reusable, recyclable, or maybe compostable. So this requires a combination of redesign and innovation in business models, materials, packaging design, and reprocessing technology. So compostable plastic packaging is not a blanket solution, I would say, but rather one specific, like one for a specific applications. Maybe targeted applications are there for this kind of compostable plastics. because an effective collection and composting infrastructure is essential, but it is often not in place. So the other solution is to circulate all the plastic items we use to keep them in economy and keep them out of the environment. So no plastic should end up in the environment, and landfills, maybe the incineration. And sometimes we talk about the waste to energy. They are not long-term solutions that support a circular economy. So what the governments can do is, the governments, they are the essential in setting up effective collection infrastructure, and they can facilitate the establishment of related self-sustaining funding mechanisms, and they can provide, and in cases they can enable regulatory and policy landscape. So businesses like producing and maybe sometimes selling packaging, they can have again a responsibility beyond the design, and also they can use of their packaging, which include the contributing towards it being collected, like take back system, and then reuse, recycled, or composted in practice. So according to the Ellen MacArthur Foundation for a Vision for the Circular Economy for the Plastics, there are six key points to be considered, as I have listed these key 6 points. So the elimination of the problematic or unnecessary plastic packaging through redesign, innovation, and new delivery models as priority. And the second point is reuse models are applied where relevant, reducing the need for single-use packaging. Third one is all plastic packaging is 100% reusable, recyclable, or compostable. And the fourth aspect is all plastic packaging is reused, recycled, or composted in practice. Fifth one is about the use of plastic is fully decoupled from the consumption of finite resources. And finally, it's all about the all plastic packaging, which is free of hazardous chemicals, and the health, safety, and rights of all people involved are respected. So in this slide, what you can see is some more examples for plastic-free options, such as solid products. If you can remember the example that I gave, Lush Company, uh, that is like packaging without packaging, or nude packaging we call. So other example is packaging free foods, or like edible packaging, as I mentioned earlier. And they can also go for the giving incentives for, sometimes in some cafeteria you can use a cup, like reusable cups, so rather than using the single use ones. And we know that if you check the circular economy itself, so it's trying to decouple the economic growth from resource use and associated environmental impacts. So in the context of the natural resources management, so there are two modes of decoupling that can be distinguished. Like if you take the resource decoupling, or we call dematerialization, which involves reducing the rate at which the natural resources are used per unit of economic output, or else impact the decoupling, like seeking to increase the economic activity while decreasing the carbon emissions or deconstruction of the biodiversity. So if you look into the water sector, so in the development of the circular water economy, the aim is to design out the externalities and try to keep the resources in use, all while regenerating the natural capital. So and the circular water economy optimizes the amount of energy, the amount of minerals, and the amount of chemicals that are being used in the operation of the water systems in concert with the other systems, and try to optimize the consumptive use of water, etc. So not only that, the circular water economy optimizes the resource yields, such as the water use and the reuse, but also the pollution prevention, and also it ensures the minimum disruption to natural water systems from human interaction and use. So not only that, the circular water economy helps to mitigate the climate change in the end, and also it enhances the resilience to the climate change. So these are the circular economy approaches in the different sectors. So this is about the 3R principle that we are talking in the circular water economy: reduce, reuse, and recycle, and the recovery. And sometimes we talk about the 4R, and sometimes we talk about the 7R concept, and beyond that, we are talking about the 10R concept as well. And this is again the 10R concept that I talk right now. So that is about the an application in the construction sector. If you take, so it's also producing and consuming, producing a lot of waste, and at the same time consuming lot of energy and water. So going beyond this 3R concept, 4R concept, and the 7R, so they have introduced recently, they have stressed the importance of considering up to 10R strategies. So starting from the R0, that is refuse and rethink. That means whenever you want to buy a product, for instance, you go to a supermarket, wherever you want to buy the product, and then you think whether you really need, do I really need this product? So that is the rethink. And if it is not necessary, you can refuse to purchase that material or the product. That is meant by the R0, the refuse and the rethink mentality. And then once you use the material, then you can reduce it, and then you can resell or reuse it, and repairing whenever possible, and refurbish, remanufacture, repurpose, etc. And then comes the recycle, and whenever possible you can go for recovery and the remining. So remining means maybe you can look into the like rare minerals and some other precious materials, uh, maybe ended up in the landfills or in the resource like recovery facilities, etc. So this for the 10R concept is built upon the so-called Lansing's ladder. Sometimes we refer to as the hierarchy for waste management, which was intended invented in 1979. So please excuse me for a minute. Sorry for the inconvenience. So this 10R concept was built upon the Lansing's ladder, that is the hierarchy for the waste management. Uh, and these strategies are ordered by the priority depending on the level of circularity. That is R0 being the higher circularity level, and R9 being the lower circularity level. And so these are some more examples that you can apply the circular economy principles in other sectors, like in the construction sector. So this is in the that is another concept that we call the design for deconstruction, that is applied in the circular economy in the construction sector. It's a very good example in the world. So that is a building. It's called the Circular Pavilion, which is located in the Paris in France. So this is the purpose of having this building is as a temporary public exhibition space, which is built entirely from the reused materials. So that is another concept that you apply in the circular economy design for deconstruction, so that you can deassemble all the materials or the parts, and then you can reuse in another application when this intended purpose is no longer needed. And is another example that I found, a very good example that we can find in Sri Lanka, from Sri Lanka. So if you have visited this place in Candies, or this is a so-called religious place, and Mbakate Valley, so that is in our local language we call this Keni Mandala or Madal Kurupawa. That is, it's also designed for deconstruction, thinking about the nature. So that is a traditional wooden king post used in the Candian architecture, especially in order to secure multiple rafters without nails or without adhesive, and allowing for easier disassembly and whenever needed, maybe if you want to replace the rafters in some cases when it is damaged or so on, so that you can reuse it as well. And another example is use of timber joineries, or in the traditional buildings in Sri Lanka, they often employed like timber joinery techniques that has facilitated the disassembly and reuse of the structured components. So uh, if you look into Sri Lanka, so in you do not have widely documented large-scale construction projects which are designed explicitly for the design for the deconstruction, but these kind of applications are there. So however, there is a growing interest and research focus on integrating design for deconstruction principles into the Sri Lankan construction industries there to promote the sustainability and align with the circular economic principles. And another example or another application of the circular economy, another principle is that we always tell that we need to use the bio-based and locally sourced materials whenever possible. So this is another good example that I found in Sri Lanka. So it's called Dear Bubula in our local language, but in English, if I directly translate, it's like water bubble. So it's called the Barbarian Art and Jungle Hideaway in Dambulla in Sri Lanka. So this is actually a eco retreat which was designed by a renowned Sri Lankan artist, and it showcases like a use of reclaimed timbers, or they are utilizing 100-year-old railway sleepers, you know, the railway sleepers. So they are locally sourced wood, and they are crafted on site. And also in this construction, they have used a ramped earth wall, so that constructed using the local soil, providing the thermal mass, and also thereby reducing or minimizing the carbon footprint of this construction. And also they have used the bamboo and woven reed. So this is used for the roofing, wall paneling, and the aesthetic finishes and the natural integration. So the structure, the built environment around this is located around the existing trees, and minimal damage to the environment, and preserving the natural landscape. Not only that, this can be considered as a sustainable design where it emphasizes on the minimal environmental impact and harmony, living with harmony in the nature with the nature. And another application of the circular economies, or which is very much interested for you, this is on the renewable resources or renewable energy. So it can reduce the emissions and also the pressure on the natural resources. Like it can chart innovative pathways to net zero economies, and that can create a sustainable economic growth and the jobs, and also it can reduce the supply chain risk. And if you look into the mining sector and the green energy, so it can also reduce the emissions and pressures on the natural resources, and can also chart innovative pathways to net zero economies and create sustainable economic growth and jobs. You know that the mining and the green energy, the mining sector itself, they are releasing a lot of hazardous chemicals. And if you do it in a sustainable manner, you can reduce this kind of uh, release of the hazardous chemicals and consequently polluting the environment. And based on the literature review, it has found that there are 29 minerals that are linked to the green energy technology. And just I have just taken it from the internet, from a research paper. So if you look into these minerals like aluminum, chromium, cobalt, copper, etc., so there are 29 minerals they are linking to the green energy technologies. So I'm not going to read it out. And and the materials which are used in selected clean energy technologies. So if you look into the transport sector and also into the power generation, like if you take the transport sector itself, so we can go for the electric cars and the conventional cars as a comparison. So if you take the electric cars, you can see the usage of different materials like copper, metals, and lithium, nickel, etc., and the amount of these minerals in the conventional car manufacturing, and also again looking into the power generations, or considering offshore wind, onshore wind, or solar photovoltaics, nuclear, etc. And these are different amounts of these components applied or used in these sectors. And another big industrial area or a concept that we are talking under the circular economy is the industrial symbiosis and the sustainable development. So we know sustainable development, of course, it's a buzzword that we are talking nowadays. And the industrial symbiosis is actually a business that is focused approach to promoting the sustainability by recovering the residues from one entity to for use in another entity. So if I give a very simple example, so there will be an industrial zone in a particular area of a country or a region, so that one factory or one manufacturing entity can produce some waste. So this waste can be an input for another company or a manufacturing entity in the same industrial zone. So that is simply referred to as the industrial symbiosis. So they work in a symbiosis that the waste generation is minimized and the natural resource extraction is minimized, and whatever the possibilities of reusing, recycling is applied there. And this is not a very new concept, the industrial symbiosis, but this is practiced for more than 20 years. And this has become a subfield of the new concept of the circular economy over the last 5 to 6 years. So this is actually follows a similar evolutionary path to the sustainable development, but at a faster pace, I would say. And these are the final slides of the presentation, so where I would be focusing on the circular economy indicators. So there are actually there's a monitoring framework on the circular economy, which is set up by the European Commission, consists of 10 indicators, some of which are further broken down into sub-thematic areas. So the first thematic area is the production and consumption, as you can see in this slide. So this area again comprises of 4 indicators, as I have listed here. So the first one is the self-sufficiency of raw materials for the production, and the second one is about the green public procurement as an indicator for financing aspect, and the waste generation as the third sub area as an indicator for the consumption aspects, and finally about the food waste generation. So monitoring the production and the consumption phase is really, really essential, because for understanding the progress towards the circular economy. So if you take the households and the economic sectors, they should decrease the amount of waste that they generate, and in the longer terms, in the long run, this behavior can or may contribute to an increasing self-sufficiency of the selected raw materials for the production. And this was developed in the European Union, but this can also be applied to our economies as well. And the second sub-thematic area under these circular economy indicators is the waste management. So under this, there are 2 indicators listed out of 10. So the first indicator is the recycling rates, that is the share of the waste which can be recycled. And the second indicator is the specific waste streams, like you can focus on the packaging waste and the bio waste, e-waste, and separate sectors and separate focus on those areas. And the third one is about that is the third sub-thematic area under this the framework, and this is on the secondary raw materials. And that has actually two indicators, that is the contribution of the recycled materials to raw materials demand, and also about the trade of the recyclable raw materials. And the fourth one is about the competitiveness and the innovation. So I'm not going to go into very details of these indicators. I just want you to know that there are certain indicators applied in the circular economy, and there are frameworks available on circular economy, and there are policies available so that we can extract, or we can grab some of these, and then we can apply it in a different context. And this fourth one is about the competitiveness and the innovation. And this area comprises two indicators, like the private investments, job creations, and the gross value added. And the second indicator is the patents related to recycling and the secondary raw materials as a proxy for the innovation. And I think those are those 10 indicators that are applied, or that are used or included in the monitoring framework of the circular economy, which is set up by the European Commission. And so in the last slide, what I wanted to discuss is about some of the benefits of the circular economy. So the circular economy offers an opportunity to reinvent our economy and to make it more sustainable and competitive. So this actually brings the benefits for the businesses, industries, and citizens, such as it can create more innovative and efficient ways of producing and consuming. So because we plan it from the design stage itself, and there will be a protection for the businesses against scarcity of the resources and volatile prices. And also there is an opportunity, or there are many opportunities for local job creation, thereby the social integration is enhanced. And the fourth one is the optimization of the waste management, which can boost the recycling, and ultimately it can reduce the landfill, the area required to generate to have the landfills, and the waste incineration is minimized, and also the energy savings, as less production processes requires less energy. And finally, it benefits the environment in terms of climate and biodiversity, and also the air pollution is minimized, soil pollution is minimized, and the soil structure improves, and also the water pollution is reduced. So this is again just a diagram to memorize, or just for your idea that what are the benefits of the circular economies, or the raw material conservation. Innovation is there because at the design stage itself, you have to think of the end of use of the product, so that the innovation is included in the production design stage, and then the durable product should be produced, and targeting the long lasting, and the job creation, because sourcing, recycling, all these things require so it creates jobs. And the efficiency, as I mentioned, water use efficiency, energy use efficiency, and everything is there, natural resource efficiency, use efficiency. And ultimately, it reduces the carbon dioxide emission and ultimately it can lead to the climate change. I mean, it reduces the extreme events of the climate change. So, however, although we talk about a lot about the benefits of the circular economy and trying to shift from this so-called linear economy to the circular economy, there are very limitations of adopting the circular economy and totally shifting to the circular economy, because there are technical barriers like such as inappropriate technology would be there. And also, if you take some developing countries compared to the developed countries, they have lack of technical support as well as the training. Capacity building is required, and there are economic barriers such as the capital requirements to shift to the circular economy. And even if you have if the technology is introduced by the developed countries, then there will be a high initial cost. Or maybe the companies they have the uncertain return and the profit, because the manufacturers, they are focusing on the profit, and they are sometimes reluctant to get rid of the existing technology and moving to this high initial cost required technologies. And also there are barriers from the institutions, and the regulatory barriers are also there. And also, if you take the developing, least developed countries, there are the lack of regulations which are governing the legal competition among the companies. And also, there are lack of environmental awareness on the part of the suppliers and the clients. So these are the main limitations of the circular economy. And so just to summarize what I have been talking during these 90 minutes. So the circular economy is built on these the three premises, that is the economy and the society. They are embedded into the natural environment, which is finite and supports our wealth, health, as well as the well-being. And the second premise is the socio-economic metabolism of the modern societies that plays a crucial role, significant role in their functioning, and has operated in a mostly in a linear fashion. And the third premise is that the efficient and the circular use of materials may reduce the environmental impact of societal metabolism, and it offers additional economic and social benefits. So this is an economic system which aims to achieve sustainability goals through more efficient and circular use of materials, and it is expected to protect the environment and being additional economic and social benefits. So what the circular economy tries is, it tries to replace the linear model of take, make, dispose with the model in which materials as well as the products, they are used more intensively but for a longer and repeatedly. So the achievement of this model requires great changes in the product design, and the business models need to be changed, and also the supply chain management is very much required, and also the government policy should be changed, and also the waste management is of concern. And if you take the linear economy, the succession of the life cycle stages implies like an irreversible transformation of the raw materials into waste, but with only a minor fraction of materials escaping disposal through recycling. So by contrast, in the circular economy, the products are reused and shared, and they are repaired or remanufactured. So together with the increased recycling rates, these activities can minimize the material extraction, the raw material extraction, and thereby save the virgin materials as it is in they can be in the earth for the future extraction when necessary, and again the waste disposal. So this is just a summary, pictorial summary of the linear economy versus circular economy. So in the linear economy, you can have the material extraction, production, use, and the waste disposal. Sometimes recycling practices are happening, but in the circular economy, starting from the material extraction, the production, use, reuse, share, and repair, manufacture, everything is circulated, and then whatever the waste coming after use, they are disposed, and sometimes uh, again circulates in the loop. So before I conclude, I just wanted to show this small video so that you will be getting an idea of the regeneration of the circular economy. I think we can watch this.
Excuse me, ma'am. Sound is not there in the video.
Oh, sorry. Wait, I have to share. Give me a second, so I have to. Let me know if the sound is still not there. Can you hear it now?
Yeah, now it's fine, man.
Okay, sorry.
Yes.
The question we asked ourselves when we started the foundation was, what's the goal? Where were we actually trying to get to? How can our economy really run in the long term when it's dependent on taking a material out of the ground, making something out of it, and ultimately throwing it away? We thought there had to be another way. Surely there's a way we could build our economy by design from the outset, so that it could be regenerative, restorative, and the more that we did of it, the better. And we started to look into different schools of thought, like cradle-to-cradle design, industrial symbiosis, biomimicry, the performance economy, sharing economy. Different ideas that really enable different business models to thrive and economy to function in a very different way. We chose to work in 4 areas. To inspire a generation in our work with education, we now have an international universities program. With business, cities, regions and government, we wanted to catalyse change, to really find collaborations that can help this to be unlocked at scale. And then on analysis and insight, we wanted to work to prove the economic rationale for a circular economy. What's this worth the global economy? Will it deliver growth? And we found that it really did. Growth decoupled from resource constraints. And on top of all of that was communication, taking this out to a broader audience in an innovative and creative way to help people understand just what an incredibly different economy we can have if from the outset we can design it to really work in the long term. And we've seen incredible momentum building over the last few years. It's extraordinary to see the take-up from businesses and governments. We still have a long way to go. But what's exciting is the enabling conditions are happening. We have the digital revolution with new business models across the world. We've seen change at a pace we've never seen before. If ever there's a time that we can accelerate the circular economy, we really do believe it's now.
Okay, so I think so with this message, I think I can conclude the lecture. So the goods of today are the resources of tomorrow at yesterday's resource crisis. So I just leave the space for you to think about the circular economy, what we have been talking today. And so you will be getting to know about a lot about the circular economy and its applications into the energy sector, so that you as a, I don't say that you as a students, but as a learning partner, so you can contribute a lot to the environment. So thank you very much for your attention. And if you have any questions, you can ask. Otherwise, I can stop the lecture. I will be sharing the recording as well as the slides with you in the LMS. I don't know whether you have got the access to the LMS yet, or I'll check it.
Hi, ma'am. Could you please share the slides before the lecture?
Yes, that is also possible. So what we've been doing is like we didn't share it earlier, but if you need, I can do it. Yes. From next time, I'll do it.
Then it will
Do
be
you have?
easier for us
Yes,
to
yes.
make a
Yes, to make the questions and all.
notes.
Yes, I know. And do you have the access to the LMS already?
No, madam.
Not yet.
Yeah, probably next week we will receive.
Okay, yes. So I'll ask from Richard and see when you will be getting. So once I get the, once you get the access, so you can watch the recording as the presentation as well. But beforehand, if there is a possibility for me to share these through an email, so I'll do so. I'll just check and let you know. There's a question asking about how is the circular economy related to ESG, environment and safety goals of UN. Is it ESG or maybe he's asking about the sustainable development goals? So actually there's a, if you take the ESG like environmental, social and governance and the circular economy, so they are both strongly emerging concepts. So these terms they are frequently used in the discourse of the sustainable development and as well as in the corporate social responsibility by maybe the policymakers or the enterprises, NGO scientists, etc. So both these concepts are fundamental for various actors but the question is where are these intertwinements and the resulting possibilities of cooperation and synergies. That's a question. So I think I have like a how do you call the note on this about these relationships, and also I'll be sharing this as well in the LMS group so that you can refer and then you can read it leisurely and understand it. Or else I'll include it, I'll make a note of it and then I'll include it in the next lecture. You take Sri Lanka, we don't have a separate so-called circular economy policy, but there are policies and all. If you take the National Environmental Act, so there are certain areas that they are indirectly included. They have included the circular economy approaches and the practices. Like in the waste management also, we are talking about reduce, reuse, recycle, and so on. So these are the same things that we are talking under the circular economy. So there are overlapping areas in the sustainable development goals and the circular economy. We are talking the same in many areas. So there's a question on what are the key reference books for this module. So if you want to learn the basics from the scratch about the in circular economy. So you can refer to this Ellen MacArthur Foundation that I mentioned. So all these butterfly diagrams and all the basic things that I explained, so they are included in this Ellen MacArthur Foundation, and they have many videos produced on different areas and different sectors, how they have applied the circular economy principles and so on. But other than that, if you need, there are books, ebooks available. And I also have some books. I'll check into the list of the books that I have, and I'll share a link. And maybe if some of you are interested, I can lend those books as well about the recent applications and knowledge on the circular economy. Other than that, I'll share some other links for the books. So maybe in the next lecture, so I can do that as well. I'll make a note of it. Okay. There are no more questions. I think we can wind up. Okay. So have a good weekend, and wish you all the best.